Okay, this is a rundown of the Bump and Go program and also an introduction to subroutines. So if we get started at the top, here we've got our usual configuration that we have for the Half-a-Bot. Nothing new here. And here we get some new stuff, define. So define is a compiler directive as indicated by that little key there. So what does define do? In this case, we're going to use it to assign an alias to our pins. So here we say define button port C4. So if you look at your Half-a-Bot board, you will see that we've got the button on there, and that button is connected directly to pin C4. So in order for us to make it easier to change our program or to maybe use this program on a different microcontroller, we give it a new name. And this also makes it easier for us to read the program when we are going down the program. So we don't have to remember the ports and the pins and all these things. We just know that if I use button in my program, the button is going to be read or written to. This is the same for left motor and right motor and left reverse, left bumper and right bumper. Again, if you look at your Half-a-Bot board, you will see pin A5 says dir1. So A5 is the direction for motor 1. And here I'm going to call it left reverse. And A4 is the direction for motor 2, and I'm going to call it right reverse. So the way that the board is set up is you need two control signals to control a motor. The one control signal is to turn the motor on or off, which is on pin C5 for the left motor and on pin C for the right motor. So if you turn pin 5 on, you will turn the left motor on, and if you turn pin C6 on, you will turn the right motor on. And if you want that motor to reverse, you turn port A5 on for the left motor and pin A4 for the right motor. And I give the bumper some names as well. Port B5 is our left bumper and port B4 is our right bumper. So now instead of using the port names and having to remember what every port or every pin connected to that port is and having to remember what the port's function is, I can simply call the name that I'm using. So here when I'm doing my dir, left motor is now an output. So left motor we know is port C5. So here it's making port C5 an output. The same with right motor, left reverse, right reverse, etc. etc. So this define is being used to give a new name to our pin, which makes it easier for us to read the program. Right. Again, variables. Here we're not using variables, so I didn't bother with any variables. Now we're coming to something new, wait while. We are all familiar with wait. Wait just waits a certain amount, but this here will wait until button, which we can remember is pin C4. So here already it's helping us. Wait while button is equal to 1. So if you remember from the building video of the chassis, we are using pull up and pull down resistors for the bumpers. So the button here is connected to a pull up resistor. So it means if you don't press the button, it is positive 5 volt. And the moment you press the button, it becomes 0 volt. So what this little command is doing, it is halting the program until you press the button. So the reason why I put that in there is sometimes when you flash the program onto your Half-a-Bot and it's still plugged into your computer and it's still on the desk and everything, all the motors will suddenly start turning and this thing will run off and fall off the desk and pull the USB cable out. It's just chaos. So I added that command so that the robot wait until we press the button to start moving. That's pretty much that. Okay, main, label, we are all happy with that. So when we start our program, we turn off the reverses so that the robot will go forward, and we turn both motors on. So our two motors will start running forward. So our robot starts running forward. Now we come to something new. If left bumper equals 1, and it says here the comment if the left bumper is pressed. So if you remember again from the half-a-bot build of the chassis, that video, it says we're using a pull down resistor. So the bumper, if it's not pressed, it reads a 0. And the moment you press it, it reads 1. So this says if the left bumper is pressed, i.e. did the robot bump on the left side. And what do? We turn the motors off and we wait 10 milliseconds. So the reason why I wait 10 milliseconds here, it says here back EMF. A DC motor has got coils in it. And when the electricity is taken away from a coil, the magnetic field collapses. And that causes some electricity to be generated. And that electricity is called back EMF. And it is a very bad idea to turn the direction of a motor, change it suddenly, because that back EMF is still working against the change in polarity. So I turn the motors off and I wait 10 milliseconds for that magnetic field to collapse. Then we turn reverse on, both reverses, and we turn the two motors on again. So here the half-a-bot now reverses away. It runs away for 500 milliseconds, about half a second, and then I let it stop by turning all the motors off and the reverses off. And again 10 milliseconds for the back EMF. And now, because it was the left bumper that was bumped, we turn right reverse on. And this will now let it turn in a certain direction. I can't remember, this has been a while. So it turns away from the left bumper while reversing. Yes. And then it stops, and then I turn everything off again, and that's my end if. Okay. The same with the right bumper. If the right bumper gets bumped, it goes through the entire rigmarole of essentially stopping the motors, going into reverse, again stopping the motors, turning away from where it was bumped, and then stopping. Or everything gets turned off again, just to keep it, or to put it into a known state. Okay. So what we look at, and then it says go to main again, and it turns everything on again, and it starts going forward. If and end if work together. So what this program is doing, it lets the robot go forward by using these commands. Then it checks, have a bumper been pressed? If that bumper have not been pressed, it skips all this code down to end if and looks if a different bumper has been pressed. If that bumper has not been pressed, it skips all this code down to the end if, and if nothing has happened, it goes back to main and starts again. Now, if the bumper gets pressed, it executes all this code up until the end if. The same with the other bumper. If it gets bumped, then it executes all this code. And this is called conditional execution. If something happened, then do something. And that's pretty much how an if statement works. All this other stuff that's happening inside here, this is just for it to go in reverse and move away and things like that. A bit sloppy programming if you think about it. And that is why, because of this sloppy programming, we need to use subroutines to make it even more easy to read this program. So what I'm going to do is I'm going to make a subroutine called reverse, and it's going to come here, and I'm going to say, okay, subroutine called reverse, and I'm going to say end sub. End sub. Okay, so in here is going to be reverse. When it needs to reverse, it turns the motor off, both of them. It waits 10 milliseconds. It turns the reverses on, and it lets them run for 500 milliseconds, and then it turns everything off and waits for 10 milliseconds. And then here it starts. So this code here, you will notice, gets repeated here as well. So I'm going to say, okay, cut, and I'm going to chuck it in here in my subroutine. Paste. Okay, and now let's just see if the right bumper gets it. Set the motor off up until wait 10 milliseconds. Now, does that look the same? Yes. Okay, now I'm just going to say I want to make it reverse, and here reverse. So what's happening here? If the left bumper gets pressed, then reverse. And if we go here to reverse, sub reverse, it says turn the motors off, wait 10 milliseconds, turn all the reverses on, let the motor run for 500 milliseconds, then turn all the reverses and everything off. Basically turn the motors off and wait 10 milliseconds. And then it goes back, and now it reverses on the left side. You will notice here it will reverse on the right side because the right bumper has been pressed. So now it makes my program much easier to read. If it says if the bumper is pressed, then reverse. It calls the subroutine called reverse and runs it, and it's all very pretty. And that is subroutines. Another thing that I want you to note is called indenting. You will see that my if statement, I put a little space behind it so that all my commands are slightly inside the if statement. You will also see that SynWrite gives us a nice little bracket here where the if and the end if ends to make it easier for us to read. But some compilers don't do that. So what we do is we do indenting. We just put a little space, and then we know immediately that those commands go with that statement, that block of commands. The same here with the subroutine. I just retained the little spacing. Whoops, what did I do there? Okay, and that is subroutines and bump and go.